Some of you with a physics background may have already recognized what you just saw. These are the eigen wave functions of the three-dimensional quantum harmonic oscillator, written in polar coordinates. The different shapes represent the probability of finding a particle confined inside the potential well. Everything you're seeing here is generated entirely inside Blender using a custom add-on called Quantum Volume, which you can download from the link in the description. Now let me show you how you can generate these kinds of wave function visualizations yourself using the add-on. First, make sure the add-on is installed and enabled, and that you're using the latest version. You can check this in Blender Preferences under Add-ons. Next, switch to the Geometry Nodes workspace. Press Shift+A and add the node group called Full Wave Function HO. As soon as you add it, a volumetric cloud will appear. By default, this corresponds to a simple p-type orbital. At this stage, no materials are applied. The add-on includes 3 bundled materials: abstract glass, point cloud, and volume. Go to the shader editor, press Shift+A, and add these materials. Once they're created, you can assign them directly from the drop-down menus in the Geometry Nodes modifier, as shown here. You can change the wave function shape by adjusting the quantum numbers in the modifier panel, the principal quantum number n, the angular momentum L, and its projection m. The node setup also exposes resolution and sampling controls, so you can balance visual detail against performance depending on your system. By default, volume plot is enabled. This gives you a smooth volumetric density cloud and is relatively light on the CPU. If you turn volume plot off, the representation switches to a point cloud. And if you enable abstract mesh, the add-on extracts an organic surface from the density field and applies a glass material. This is the mode you saw at the beginning of the video. From here, you can animate the object like any other geometry in Blender. You can rotate it, or enable the dynamic mesh option to introduce subtle, frame-by-frame motion so the structure behaves like a living, moving surface.